Alright, and welcome to square root transformations. Now, in number 1, it says the function f of x equals the square root of x plus 1 is transformed to g of x equals 1 half square root of x plus 2 minus 1. And we start this by graphing both of the functions. Now, the way that you want to graph a square root function is you first want to find the vertex. I'm going to label my f of x, or everything that is f of x, in orange, and I'm going to label my g of x in this nice pastel blue. And so the first thing that you want to do is you want to find the vertex of both. Now, how do you find the vertex? Well, you always look on the inside of the function at this x plus 1, and you always set that, we call that the grouping, we set it equal to 0. So, minus 1, and we have x equals negative 1. And so my vertex, the x value is negative 1, comma, and we see our k value, that constant on the outside, we write it as it is. Our vertex is h comma k, or negative 1, positive 1. And notice that my a value is a positive 1, so this graph just opens normally and up. Now let's take a look at g of x. For g of x, I see that inside the grouping for the vertex, we have x plus 2. We'll of course set that equal to 0. And we'll subtract 2, and x is equal to negative 2. Comma, my k value is negative 1. So my h comma k, or my vertex for g of x, goes to the left 2, and of course down 1. And notice here that my a value is still positive, so it opens up, but it's the fraction 1 half, which is less than 1. I'll write that a is less than 1. So that means it's vertically compressed. It opens up at a very slow rate compared to the original function. Now from here, we actually don't need to do any math. We could just visually look at this and label it. So how did this transform? Well, it clearly shifted to the left 1. So we can write, hey, it went to the left 1, comma, let me make that better, 1, comma, it went down 1, 2, say down 2. And since our a value went from 1 to 1 half, since we decreased, we could say that, hey, this was vertically compressed. Now, to write the rule, I want to show you a very easy way to do this. So I want you to finish taking your notes, pause the video, and let's clean this up just a little bit. Okay, so here you'll notice that I just rewrote g of x and f of x. And this is very important. You always want to put the second function, the one that we're transforming to, you want to put it on the top, and our first function, you want to put it on the bottom. Now, I'm actually going to break this up into kind of 3 pieces, and here's what we do. In order to find our a value, we always take the f of x, or the second function, in this case g of x, and we divide it by our a value of our first function, which in this case is 1. So 1 half divided by 1 is simply 1 half. And so our a value for our rule is 1 half. I then take what's inside the grouping, the plus 2, the plus 1, and what I do is I always subtract them. So 2 minus 1 is of course a positive 1. And that's going to be the value that we include for the h. Now for here, so that's kind of in the h position. For here, we have negative 1 minus positive 1, and so negative 1 minus 1 is actually negative 2. And remember, that's going to be for our k value. So from here, we can actually write our rule that transforms us into g of x. F of x is transformed to g of x with this rule. 1 half, parentheses, let me include something, 1 half f of x plus 1, and then of course minus 2. So notice I just wrote the 1 half, I wrote this inside the grouping, and I wrote the negative 2 for our k value. This 1 half gives us a vertical compression. This plus 1 actually shifts us to the left 1, and this minus 2 shifts us down 2. And here is the rule that transformed the two functions. Alright, let's move on to our second example. Okay, here we have example 2. In example 2, we have our function f of x and g of x, and the first thing we want to do is graph both of them to see how they transform. So I take my grouping of f of x, this x plus 1, and of course I set it equal to 0. Now I subtract 1 from both sides, x is equal to negative 1, and my vertex is negative 1, comma, 3. And remember that is our h comma k. Now, in this blue, this is where I have g of x. I take my grouping, this x plus 4, I set it equal to 0. And of course, to get rid of the positive 4, I subtract 4 from both sides. And our vertex is at negative 4, comma, positive 1. And that's my h comma k. Now from here, let's go ahead and graph these. I see that my first vertex, f of x, in orange, is negative 1, and I go up 1, 2, 3. And notice that my a value is 1, so I'm going to open up at a normal rate of increase, and we're just going to go to the right. Now, let's go ahead and take a look at our g of x function. Here I go to the left 1, 2, 3, 4, and I have a positive 1, so I go to the left 4 and up 1. But notice here, my a value is negative. That means I'm going to start to go down, and it's a 3, which is greater than 1. So this rate of decrease is actually going to be much quicker or much faster than the rate of increase for the orange function, f of x. So let's go ahead and describe our transformation. We can say, hey, we went to the left 1, 2, 3. So we went to the left 3, comma, looks like we went down 1, 2. So down 2, kind of like in our first problem. And we were actually reflected down, or we would say reflected across the x-axis. And the last thing that I'll just kind of write up here is, since we went from a 1 to a 3, since our a value increased, we actually have a vertical stretch. Now, let's go ahead and write the rule. So I would encourage you to pause the video, finish taking your notes, and let me clean things up just a little bit. Okay, so how in the world do I take g of x, which is, remember, our second function, and use f of x, our first function, in order to create the rule? Kind of working backwards here. Well, the first thing we do is we always look at our a values. Okay, so I'll label this column a. We take our g of x, negative 3, and I do negative 3, and we divide it by our f of x a value, which is 1. This is equal to negative 3. So aka a is equal to negative 3. Now for here, we go ahead and take what's inside of our h value. We have this 4 minus this positive 1, and of course we get a positive 3. Okay, remember that's inside the h value, but it's not actually h, which is the confusing part. And here we have our k value, and we see that we have a 1 minus 3, which is negative 2. Now this one actually is your k value. Okay, and this allows us to write our rule. We'd say this. We'd say g of x is equal to, you write your a value, negative 3, and then you write f, because remember this is the rule that transforms us from f of x to g of x. And then since our x value is positive 3, we write, we're actually going to write this plus 3 on the outside. It's not our h value, but it is what goes here. And then we drop our minus 2. Now from here, you can notice that this rule accurately describes our transformation earlier. See, the negative, it will reflect us across the x-axis. This positive 3 means that we have a vertical stretch. Here, x plus 3, remember, this x is actually negative 3. This is what shifts us to the left 3, and this negative 2 shifts us down 2. So this is the rule that we were looking for. Alright, I hope this video was helpful. I know that this is a little bit of a difficult skill. If you need to rewatch the video, that's okay. Rewatch the video. And I'll see y'all in our next video.